I think we can start. So, uh, hi, my name is Harun Denizli, and I'm going to talk about special solutions for natural refrigerant heat exchangers. So, this is my content. I'm going to talk about the introduction and natural refrigerant. So, what are we doing in the free time about the natural refrigerant heat exchangers? So, after that, we are looking heat rejection systems and evaporators. And as an introduction, as you know, in the fight against increasing carbon emissions and climate change, the use of natural refrigerant in the HVAC sector is of great importance. So, natural refrigerants such as ammonia, carbon dioxide, and hydrocarbons has lower global warming potential to the environment, and it's making them less harmful to the environment. So their use improves system efficiency while reducing the carbon emission, carbon footprint, contributing to more sustainable energy. So, what makes them, what make these natural refrigerants distinctive? When we look at this table, as you can see, these are the thermophysical properties of from three most common freon refrigerant and the two most common natural refrigerants. As you can see, if you look at the CO2, the volumetric capacity is bigger than the others. So you can reduce your products and you can buy smaller products. And it will reduce your installation cost. And when we look at the vapor density, it is bigger than the others. So we can use CO2 as a gas cooler for these thermophysical properties. When we look at the ammonia, thermal conductivity and specific enthalpy is bigger than the others. So it makes more efficient than the other refrigerant system. So it will reduce your operational costs. With that, what are we doing in the FRITSEM about the natural refrigerant heat exchanger? If we need a classification, we can make it two subtitles. One of them is heat rejection, the other one is evaporator. In the heat rejection systems, we have two types, ammonia condenser and carbon dioxide gas cooler. Also, we have desuperator for the gas coolers. So in the evaporator side, we have the X evaporator and the pump evaporator for each natural refrigerant. So for the carbon dioxide system, we have Eurovent certification. And after that, for the heat rejection, we can talk about the materials. So for the pipe side, we have copper and the stainless steel pipe. For the collector side, we have copper, steel, and stainless steel collector. For the fin side, we have three material: aluminium, magnesium, and stainless steel. For your needs, we have two type coating for the aluminium. One of them is epoxy coated, the other one is hydrophilic coated. And as you can see, the blue ones is only valid for CO2 gas cooler, because ammonia makes a chemical reaction with the copper, so we cannot use in the fluid side as a material for copper. For the copper pipe, we can use strength copper pipes. We called K65 copper pipes. So if you want, we can use these products. So for them, these are the materials, but what we have for the special solution for the heat rejection system. There are three type pre-cooling system in the FreeSam. One of them is direct spray, the other one is ecomesh spraying, and the other one is adiabatic cooling system. And the most in this system, the most efficient system is the adiabatic pad system. So I can tell how it's going, how it's work. As you can see, the pads absorb water and increase its surface area, so it makes an evaporative cooling in the coils inlet. So as you can see, the point one is the before cool pad, and the point two is after the cool pad. When, as you can see, it follows the wet bulb temperature. When we increase the humidity, as you can see, we can decrease the dry bulb temperature in the coil inlet. So especially in the ammonia system, for the better efficiency, they want to make 35-degree condensing temperature. So even though in the 40-degree ambient temperature, with using this system, you can reach 35-degree condensing temperature. If we talk about the system, we have two types. One of them is with pump, the other one is without pump. In the without pump system, when we send the water in the upper tray and it goes on the pad's side, and pads absorb some water, and the wastewater goes to the bottom tray, and it exits the system. Some customers wants to take these water and make some filtering and reuse it. For that, we make a with pump system. We can use wastewater thanks to the pump, but there are some problems in here, because when you make too much recycling, water gets harder and harder, so it will reduce your pad's lifetime. So for that, we have an option that bleed off system, so it will renew your bottom trays water, so it will increase your pad's lifetime. After that, we have evaporator material systems, and as you can see, the materials are the same for the evaporator, but I want to mention that each section has stainless steel. So especially in the hygienic systems, we can provide whole stainless steel products. Especially in the food market, they want to buy something like that, something like these products. And as you can see, we can provide all of these casings, collectors, pipe, and stainless steel. We can provide in the coil and the product with fans. For your needs, if you need angled fan hoods, we can provide 90 and 135 degree angled hoods, and we can make blast freezer whole stainless steel, and that's it. For the special solutions, we have defrost types. As you know, these are the systems that can provide free temp can provide you, and these are electrical defrost and hot gas defrost and interlaced hot glycol defrost. And these defrost types, it has different advantages and disadvantages. For example, hot gas defrost generally used in the ammonia systems, ammonia evaporators, and hot glycol defrost system gives an option that you can use waste heat from the condenser to the melting your frost. So you can make an energy saving with using this hot glycol system. But there is a limitation in this system, especially in the below minus 18 degrees. The efficiencies is very low, so we don't recommend to use minus 18 degrees, below minus 18 degrees. Below minus 18 degrees, we suggest that using the electrical defrost systems. And as you can see, we can provide you that's what you need. So towards a sustainable future with natural refrigerants, free time heat exchangers. Thank you for your listening.